So basics of probability and statistics. So this is very important. So the slide which I'm showing you now, this is the basis of your machine learning. So imagine this. This is your population. So when we have the data of the population. What is population? Population is everything. So if I'm collecting the data of everything, then that's a population data. But if I perform my algorithms, which we'll be learning in the future classes, if we'll be doing our analysis on the population data, just imagine how much time will it take. So what we do, we use sampling techniques and then we will bring out a sample. So we'll be taking this out of population, we'll be extracting the sample. How will extract the sample? Based on sampling technique. And then we perform our analysis on this sample. Okay. See, the reason why I'm stressing so much on sample, because your machine learning is completely dependent on samples. So we'll extract the sample using some sampling techniques. We'll have a look what are those sampling techniques, but first understand this flowchart. So we have extracted the sample now. We perform our descriptive analytics. We do lot of analysis, and this analysis on the sample is called descriptive analytics or descriptive statistics. Now, using sample, we do a lot of analysis, lot of descriptive analytics, or lot of descriptive statistics. And then based on this analysis, we infer, see, when we do analysis, we'll get some results. And then using those results, we'll infer and we'll draw the conclusion for population. Okay, so it's like a loop. So to give a simple example here, just imagine I have one place, suppose let's take I have one land, there I have lot of companies, say 1,000 of companies, and I cannot read the data of 1,000 of companies. So what I do, I will take the sample. Say I take the sample, I say 50 to 60 samples, okay? And what I see, if I take the sample of 50 to 60 companies and I read about those companies, and if I see those 50 to 60 companies are say Mercedes-Benz, BMW, or say Porsche, or say Chrysler or something else, okay? So what I am understanding from this, so what I can infer about the population, I can infer that all the 1,000 companies might be, okay? Understand this, because we are predicting, we are not telling something certainly, we are predicting. So might be all the companies in that area would be mechanical industry or automobile industry. That is what we are predicting, right? This is how we do descriptive statistics and inferential statistics. What is inferential statistics? Based on the sample results, we are inferring something about population. So that is inferential statistics. Now, see, the reason why I have focused so much on this flowchart, because this is the basis of your machine learning. Now, what are the sampling techniques? In the broader picture, sampling is divided into two. One is probability sampling method. The other one is non-probability sampling methods. See, non-probability is pretty simple. I don't want to get into more detail over there. There are a lot of non-probability sampling methods, okay, first of all. But this non-probability sampling methods would be slightly biased, okay, because we understand probability is for unbiased, right? So we cannot go with non-probability sampling methods for our analysis. We should always go with probability sampling methods. We should always go with probability sampling methods. So now these are divided into four. The first one is simple random sampling. Now in this example, I have 1,000 companies. I have say sampled 50 companies. How would I do that? Say all the 1,000 companies are lined in one after other, first, second, third, so on. How would I sample them? Or let's take a even further simple example. I have 10 boys and 5 girls, and I want to form a team of 3 members, which I will be sending for national competitions. So how would I sample these 3 people from this 10 male and 5 females? So out of 15, I will do simple random sampling. Simple random sampling is I will directly choose 3 people randomly. That is called as simple random sampling. What is systematic sampling? For example, if I number the people 1, 2, 3, so on up to 15, okay? And if I want 3 people for my team who will be going for nationals, So what I will do using systematic sampling, that means what is systematic sampling? Systematic, right? Simple English word, systematic. So for example, I'll choose in this 15 people, I will choose 5th person, 10th person and 15th person. Simple, systematic sampling, right? Stratified sampling. This is mostly, so simple random sampling and stratified sampling is used in majority of the organizations. Systematic and cluster generally do not used as much as simple random sampling and stratified sampling is being used in different organizations. So what is stratified? For example, if I want to form, see, imagine in this way, I have 10 men, 5 women. I want to select a team of 3 people. Now, if I choose simple random sampling, there might be a chance all the 3 people are men, right? There could be a chance, right? So this is where stratified sampling is important. So for example, if I want to form a team of 3 people such that 2 of them should be men, 1 of them should be female. So in this case, what I do, I'll make some stratas. Stratas means groups. Okay. So I'll form a group of 10 men as one group and 5 female as other group. So out of this 10 male, I will select 2 randomly, and then out of 5 female, I'll select 1 female randomly. Okay. So this is how we do stratified sampling. I want you guys to read about clustered sampling. Okay, I will not go into that. I want you guys to do homework. And I also want you guys to read about non-probability sampling methods also, because people, a lot of interviewers also ask questions on this. So I don't want you to lose some opportunity because of this. So you can also read about it. Okay. But I'll be focusing more on important areas and you have to do the homework. Okay. Now, as I already discussed about population and sample, we all know what is mean. We have learnt in our school days, right? So let's do one simple exercise again. I have 5 numbers. Everyone note down. I have 5 numbers. 1, 2, 3, 4, 5. What would be the mean? Please write it in the chat box. 3, right? How is it 3? 1 plus 2 plus 3 plus 4 plus 5 divided by 5. So it's a simple average, right? So the mean would be calculated for population and sample using the same formula. Now what is variance? So mean is you're measuring something. It's a measure of central tendency. Variance is how much your data is variated, right? That means the measure of dispersion. Okay, for example, let me quickly draw it. So I have 5 students, right? 1, 2, 3, say 4, 5. Or you can take 1, 2, 3, 4, 5. So this is a mean 3. But this point is dispersed from the means with this quantity, right? With this much. This 3 is lying on the mean. This is again dispersed about the mean. This point is again dispersed about the mean, right? So that is the reason means variance is called measure of dispersion, and it is calculated using this formula which I am showing you. So what is xi? So what is this? Xi are the observations or the records or the numbers which I told 1, 2, 3, 4, 5. What is mean? Mean is 3, which we have already calculated. What is n? Number of observations. In this case, it is 5. What is sigma? Sigma from our school days, if you remember, this sigma is denoted for summation, right? So variance is denoted by this other sigma square. Okay, this is also called as sigma. This is also called as sigma. Do not get confused. Okay, so this is sigma square is variance and this sigma is summation. So this is how your variance is calculated. So this variance is calculated for all the observations over the mean or about the mean. Yes, you have a very good question. Why variance is always square? See, the point is, anyways, I was about to explain that. See, for example, just say that x is the observations of, say, different vehicle speeds. And we know that vehicle speed will be kilometer per hour or meter per second. So the mean will also be in same units, right? But when you take the variance, this variance has a square, right? So that's the reason. Now once we have a square for the variance, the units will become meter square per second square, right? So that's the reason it is denoted by sigma square. Now to answer your question, why it is always having square, it is very interesting question. I can understand this. In our school days we never have thought in this direction, but you have a very valid question. So this is our mean, this is 1, this is 2, this is 3, this is 4, this is 5. Now if I want to calculate the variance, the dispersion without square, just imagine without square, x minus mean, right? For this 1 minus 3, which is minus 2. For this 2 minus 3 minus 1. This is 3 minus 3, which is 0. This will be 4 minus 3, which will be 1. This is 5 minus 3, which will be 2. Now sigma means summation, right? So if I add this now, minus 2 plus minus 1 plus 0 plus 1 plus 2. Now I will get 0, right? So it has no significance. We could see that from here we have a variance, we have the dispersion, but the value is 0. It is clear from the graph we have the dispersion, but from this value it is clear that it tells there is no dispersion. So there is something wrong, right? So that is the reason we always square it. We always square it, because once we square a number, negative number will also become positive, right? So that is the reason we always square. Again, you have a very valid question. Why can't we have mod? Okay, I can answer this question, but you have to hold on. For this question, the answer will be there in third week, because I don't want to tell anything which would not make sense to you now, because I want to take one step at one point of time, so that by end of this course everyone should be able to understand what is the significance of each term. Okay, I want you guys to ask some this kind of questions, because this kind of things we have never learned in our school days, you know. Okay, now we have learned about variance. There is something called as standard deviation also, right? So standard deviation would be square root of variance, simple. So now tell me, when variance is giving us the measure of dispersion, why there is something called as standard deviation in this whole earth? Why there is something called as standard deviation? See, we know variance and standard deviation from our school days, that both are measure of dispersion. And what is standard deviation? Square root of variance. You can tell the answer, guys. You can be wrong, okay? Give me the explanation with only simple basic knowledge. When we already have variance on earth, why there is something called as standard deviation being discovered? You understood my question, everyone?
Yeah, sir, we have an answer. Standard deviation is required to estimate the capability of the process or acceptable range of variance for a process.
Okay, let's think in this direction. Yes, you all are right, but to see in this direction, okay, let me go back to the one note and then explain it in a better way. What I told, for example, if I have vehicle speeds, right? Say some vehicle are driving with 30 kilometer per hour. Some of them are driving with 50, some of them are driving with 70, some of them are driving with 90, and some of them are driving with 100. So, okay, one vehicle is driving with 30, one vehicle with 50, one with 70, one 90 and 100. If I take the mean, I can calculate the mean here. It's not a big deal. I can calculate the mean. I can also calculate the variance. But if you remember the formula for the variance, we have a square, right? And why we have a square, I have already told. So now, if we take the square, yes, the measure of dispersion will be squared. But why there is a standard deviation? That is still not answered. But if you see in this way, see what will be the units of the mean? It will be again kilometer per hour, right? But the units of variance will be kilometer square per hour square, right? So this is incorrect. For our analysis, we have to maintain the consistency with respect to units. We have learnt in our 11th class, in units and dimensions, we should maintain the consistency with respect to units. To maintain the consistency, we take the square root over here. So if I take a square root of variance, which is called as standard deviation. So this is our standard deviation, so that our units comes back to the original unit, which is kilometer per hour, right? So our measure of dispersion should go back to the original units. But you should understand that if mean is some unit, say meter per second, then variance would be meter square per second square. To bring back, and your observations are also in meter per second. To bring back the units in the same meter per second, we have to take the square root of v, which is called as standard deviation, which is again meter per second. So that is the reason, guys, there is something called as standard deviation was discovered. No, variance and standard deviation will have the units. It depends on your observations. Your units will be taken based on your observation. If your observation is in meter per second, then mean will always, see, why do we always call the average speed? Average speed means we have a units, right? And then measure of dispersion. For what we are doing? Measure of dispersion. We are measuring the dispersion of the speed with respect to mean, right? So the dispersion should also have the units, right? Getting my point? So that is the reason the units needs to be consistent. Now, the assignment for you guys, I have taken an example with 5 observations, okay? You can take an example with 10 observations, 20 observations, or 100 observations. We cannot directly use standard deviation. Tell me, could you please tell me how do we use standard deviation directly?
Actually, we have a variance and then its formula, right?
Right.
So instead of that, why can't we use standard deviation and have its own formula, square
See,
root of variance?
see why we are squaring, so that the negative values, what we have learned here, the negative dispersion and the positive dispersion should not get cancelled, right?
Yeah,
That is the reason we are squaring it.
yeah,
So,
that's right.
so when we are squaring it, we know that we are changing the units. So that is the reason we want some intermediate measure, and that intermediate measure is called as variance. And through variance, we are calculating standard deviation. If you want to write directly for a formula of standard deviation, you can directly write square root of sigma x minus mu whole square divided by n. There is no harm in that. Okay.
Yeah, yeah.
But then it's important that we know what is the significance of variance and standard deviation. See, I'm not here to do a lot of maths in this class. I'm here to explain the significance of each parameter.
Okay, sir, got it.
Again, you have brought a very good point. We can do different mathematics. Everyone can do a lot of calculation. But we should know the significance of each term, what we have learned in our school days. Okay?
Yeah, yeah, sure, sir. Thank you.
Welcome. Okay, so now the assignment for you guys, if you have the observation, say 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. Take simple random sampling and take only 3 samples, and then calculate the variance using this formula and then sample formula. So you must have noticed that there is a slight change in the formula, right, in variance and sample. So this is your assignment, guys. In our school days, our teacher might have told us that this is the formula and then we are mugged up. I don't want you to do that. In my class, I want you to tell the reason why the formula has changed. Did the mean formula change? Yes or no? Please type. No, right? Mean formula has not changed for population and sample. Then why did variance formula change? You have to think, guys, okay? Then why did variance formula has changed? Now again, this is a random variable. So for example, what can be the random variable? In the first example, if you remember, I have tossed 2 coins, right? And I wanted to check for the probability of getting 2 heads, right? A probability of getting exactly one head, a probability of getting no head. So that is our random variable. So in this case, x could be number of times we receive head when a coin is flipped, 5 times. So x equal to 1 means head is appeared 1 time. X equal to 2 means head has appeared 2 times. Okay, so that is called as random variable. Now random variable can be of 2 types. It can be of discrete, it can be of continuous. Discrete random variable, so it's very simple English, guys. Okay, what is discrete random variables? Where discrete means something for which the decimal point does not make sense. For example, number of people. Can I tell 1.5 people? No, I cannot tell 2.35 people. I can only tell 1, 2, 3, 4, 5. I can tell 1 head, 2 heads, 3 heads, 4 heads. I cannot tell 1.5 heads. So that is discrete random variable. But continuous random variable, where the decimal point makes sense. Salary, your weight can be 70.5, 70.2, right? So it makes sense, right? So that's the difference between discrete random variable and continuous random variable. Okay. So for example, number of machines which are failing would be discrete or continuous. Please write down, guys. Discrete, right? Good. So number of TVs sold, discrete or continuous? Discrete, right? Height of a person, discrete or continuous? Continuous, right? Great. So let's go ahead. I want everyone to do some simple analysis, okay? So for example, this is a Python interface, okay guys? So if I'm writing say 2 plus 2, say x equal to, I want you all, everyone to do this, okay, at your home. And we'll be sharing the guideline how to install the Python interface. And then you have to start writing this, okay? Yes, we'll do that. We'll do that. So, and then you have to write simple codes. Okay, for example, like this. And then you have to run the code. Now, if you see, I have printed x, which is 2 plus 2, so 4, right? If I want to print 2 power 100, so this is not 2 power 100 in Python, so this is what happens. So we have to remember the syntax. I believe this is the right one for 2 power 100. Yes, so this is the 2 power 100. So for some simple things which I wanted to do, guys, okay, play around with Python, okay. For example, if I want to put some characters, then characters should always be within the double quotes, okay. For example, if I want to comment this now, because I don't want to print this again and again, so I have to put hash here. So this is commented, okay. So it's taking some time to print because, yeah, I have opened this Python after a long time. Okay, so guys, you have to do in this way. You have to do a lot of practice on Python. Do simple Python, okay? I'm not asking anything more, right? Just do simple mathematics in Python. Print simple characters in Python, okay? At least with respect to some simple maths, 2 into 3, 5 into 100, something like that, so that you should get the flavor of Python, so that in next class we can go with other things. For example, some important syntaxes for such as if else, for loop, so that we can learn all those stuff, okay, in next class. For example, repeating 500 times, we have to use for loop, right? Something like that. Do some simple things, okay, and then you will start loving coding. And you have to practice, guys. In the class, I can teach you the syntaxes, I can tell you what needs to be written in coding, but until and unless you practice, you will not be familiar with the coding. You will be scared of coding. But I don't want you guys to be scared of coding. Do simple things on Python, and next session we'll be going with some complicated syntaxes. That would not be much complicated, that would also be very simple. And after that, we'll start with some algorithms, okay? So let me take the questions. You can use Sublime also, it's up to you. I generally use Visual Code Studio, but it's up to you. You can use Sublime also. Someone has answered the question of our fourth question, right? I don't want
Yes,
to.
sir.
What is the probability of drawing two jacks on a pack of card? So no, that's incorrect. You can please think on it, okay? Because the probability, right? It is probability. Probability can never be greater than 1. Okay, guys. So what I'm telling is, for the fourth question, you are telling the answer, right? Probability cannot be greater than 1. You have told the answer 44C4, which is greater than 1. Yes, you can use the Anaconda interface, but I recommend to use Visual Studio Code. It's because so that we both are on the same page, okay? So you have to work on these 6 questions. DL and AI can also be used in Python. Yes, that's the reason we are looking for Python, right? Because deep learning and artificial intelligence is in Python. We'll be doing a lot of stuff in Python. You will start liking it. Is MATLAB and Python same? To some extent, yes. The coding is very simple in Python. Python is very simple coding language. I would not say that both are same or not. To some extent, both are similar, okay? But then Python is very simple. That's the reason we have chosen Python, and that's the reason Python is in so much demand in market now.
We have used techniques, does IT engineers also use the same?
Okay, so see, if IT engineer, there is nothing such IT engineer or mechanical engineer. Those are different domains. Okay, IT, electrical, mechanical. In mechanical, again, we have a separate domain such as manufacturing, thermal, right? So we have different domains. It's not that we cannot use these techniques in IT engineer, IT domain or electrical domain. We can use this technology in every domain. IT, ECE, electrical, mechanical, in everything. Okay, but we'll be looking into a lot of mechanical examples in this course because this is developed in a way that mechanical aspirants should be interested to join this course. Okay, and others can also join this course. If they are not able to understand the example of mechanical, they can always stop me and tell me to provide some simple example. Okay, since our class is for mechanical aspirants. Yes, you can use the same techniques. See, the techniques are not changing, techniques are same. You can use the same techniques in IT, electrical also. Okay, see, by this end of this course, I would say you would be at the intermediate level, provided you practice, you complete all the challenges, projects, what we give, okay? And provided again, you spend some time on this course, do lot of practice, okay? And up to which level? So this is very important question, okay? Entry level or mid level? See, it depends on your current experience also. See, how much experience do you have now? For example, if you have 1 or 2 years, then you would be able to apply for entry level. If you have if you have 5 to 6 years, then you can apply for mid level. If you have 2 years, then you have to apply for entry level. Okay. And you don't have to worry. If you don't have to worry, your salary would be increased. If you switch the job, and you all know that data science is on high boom, right? It's booming now. So you don't have to worry whether you're joining as an entry level or mid level. Important here is learning. Learning is important, and whether with this course, are you able to get placed in different organization? Is your salary increasing? That's important. And for me, all of you should get the course. For example, not formula. I want you to understand the significance. For example, the way I have explained the significance of square in variance formula, why there is standard deviation when variance exists. Something like this, guys. That is where I will be focusing so that you can clear your interviews easily. Okay. Can ML and AI be useful for applying? Yes, you can. Okay, this is very important. Yes, there are a lot of master's course as well. Okay, in the world. So you don't have to worry for that. Will the classes be recorded or interactive? It will be from my side. All the courses will be interactive. And if you have any questions, then you can always get back to us. Is there any sync from Python to different software? Yes, you can do the same thing. What we are doing in Python, you can do the same thing in R also. But that, as I already told, it's just a matter of syntax. Python is more robust, and you can do the same thing in R, you can do the same thing in MATLAB also, but then it's just a matter of which is more robust, and most of the organizations are working in which language. Simple. Is it related more to language or math? It's related more to mathematics. Okay, it's related to maths, and I'm very close to math. Okay, math is very close to my heart, so you don't have to worry. I'll make sure that by the end of this course, you will also start liking mathematics, and then you will understand the significance of different terminologies. Oh, of course, yes. I have done a lot of simulations on external aerodynamics. I have not a lot of simulations, but I have done some simulations on external aerodynamics. It was really beneficial, believe me. Can I use this course in automotive design? Of course, yes. See, that's what I told. No, I'm also coming from CAE field. I'm coming from CFD field. I have used this ML and AI in different fields. Yes, you can. Machine learning is useful in, I'm telling you, take any domain, you will find the examples on internet for machine learning and AI with respect to that field. Okay, so before ending, okay, as I've promised that I will try to improve your logical thinking by giving puzzles, right? I have one puzzle for you guys. Are you ready for it? Meanwhile, I'll take this last question. So the first puzzle is, how many squares are there in a chessboard? Okay. Thank you everyone for joining.